Are you ready? Are you ready? Oh, are you ready to go? Are you ready? Are you ready? Are you ready to go?
Hello, it's Mr. T, and welcome to another algebra tutorial. Today we're talking about adding and subtracting rational expressions. Rational means fractions, one of your faves. All right, let's get started. When we're adding and subtracting rational expressions, the most important component here is that we must have a common denominator before we can add two fractions. If the fractions or the rational expressions we're giving have already a common denominator, then we would jump straight down here to step 3 and we add the numerators, the tops, and simplify. But the denominators, we don't add the denominators, we just take one copy of the common denominator. If our denominators are not already the same, then we have to determine what a common denominator would be, ideally the least common denominator. And we do that by finding out what factors each of the denominator is missing. We'll show this in a minute. And we have to add that. To add a missing denominator, we have to multiply that particular fraction on both the top and the bottom by that missing factor. So let's go back to grade school here and review with numbers before we get into our expressions. So we have here a fraction. So here, these are our numerators and denominators. So we have a common denominator. So we can just add across the top. And then after we add fractions, we should always try to simplify. So both the top and the bottom here are divisible by 2. So we can divide that by 2 and divide that by 2. And we get our final answer being 5/4. Here we have different denominators. So when we just have numbers, what we're looking for the least common denominator is the smallest number that both 4 and 6 will divide into. So if your math facts are okay, that would be 12, because 4 divides into 12 3 times, 6 divides into 12. When we do it with expressions here with x's, our first step is going to be to factor these. So if we kind of just review this with numbers, we could factor this into 2 times 2, and we could factor 6 into 2 times 3. Now they both already have a 2, so we don't need to do anything for that. But this one has 2 2's, this one doesn't. So this one's missing 2's. So I have to multiply top and bottom. So now I have 2 2's over here. And over here we're missing this 3, so I have to multiply by 3/3. Now we've just learned about multiplying fractions, so we multiply each fraction. So over here we have 9/12. And over here now we have 10/12. And now we have a common denominator, so we add across and we get 19/12. And that can't be simplified. There's no common number that divide into 19 and 12. So let's extend this skill and look at problems where we have letters in them. Now, as you can see here, we have a common denominator. Now, I didn't mention earlier, a key thing when you have subtraction, turn it into an addition problem. I do what I call keep, change. So I'm going to change this. And I have to change here, meaning change the sign. So I have to multiply that entire top by minus. So essentially I'm moving this minus sign up to the top and turning that into now an addition problem. So if we add across the top, I've got x plus 6y. And now I have to distribute my negative. So negative 6x and negative times negative y would be plus y. And that's over our common denominator. And now we just add like terms. So x minus 6x would be minus 5x. And we have 7y's over 12x to the 4th. And we can't simplify because there's nothing we can factor out of the top, so there's nothing we can cancel. So that would be our first example. So again, we had common denominators, so we just add across. And we talked about turning subtraction into addition by doing keep, change, change. turning this to addition and moving the minus sign to the top, essentially taking the opposite of the top. So let's look at another example. Now we do not have common denominators, so our first step would be to factor our denominators, but they're already factored. Let me move this over a little bit. So again, I'm going to change subtraction to addition. And now we have a factor. So this fraction here is missing that denominator. So I have to multiply this denominator by that whole factor. So we're treating that whole thing as a factor. And over here, we're missing the n minus 4. So I have to multiply by n minus 4 over n minus 4. And I like to put parentheses around my factors so we can see they go together. Now we're going to leave our answers in factored form. So on our denominator, our common denominator is n minus 4 times 5n plus 3. Oops, forgot the n there. And multiplication is commutative, so the order that we put those factors doesn't matter. Now on the top, we're going to have to distribute this 5n. So I'm going to have 25n squared, and then 5n times 3 is plus 15n. And now I've got to distribute this negative 6n. So I'm going to have negative 6n squared. Extend that. And negative 6n times negative 4 would be plus 24n. So now we're going to combine like terms. So we've got 25n squared and minus 6n squared. So that gives us 19n squared. And we have here 39n. And then using our skills from the last lesson, we would want to factor the top. So I can factor an n out of the top. And our bottom, but I don't have just a plain n in my denominator, so there's nothing I can cancel out. So if you're 100% sure there's nothing will cancel out, we could leave the answer like this, but it's always safest to factor the numerator just in case there might be something that can cancel out. So again, this was our final answer here. We're going to leave it in factored form, so we don't want to distribute. That would undo the work that we just did. Now let's look at one last example here. Now, ideally, we should factor this denominator, but since there are no common factors, well, actually there is a common factor. So first thing we can do here to simplify this is we should GCF factor the bottom. So I was going a little bit too quick here. So we can factor out a 2. So they already both have a 2, but this fraction is missing this. Now, we could go ahead and just multiply over here. But just in case, mainly for the last step, we might want to factor this. So let's just review here. Again, we could use the a times c factoring. So a times c is 18. We need a pair of numbers that multiply to be 18 and add to be 9. That would be 3 and 6. Remember, we're going to rewrite this denominator, or this expression, splitting this middle term. What's a b? Plus 6b plus 9, and then we're going to factor by grouping. GCF factor each group. And here we can take out a 3. And now they both have a 2b plus 3, so we can do another GCF factoring out that common binomial. So now this factored into 2b plus 3 and b plus 3. Now the reason we would want to do this is if this denominator had been, say, 2 times b plus 3 and 2 parentheses b plus 3, then we wouldn't want to multiply the other side by this. It's going to make the problem more complicated and hard to simplify. We would only multiply here. But we're missing both of those terms. So I have to multiply this fraction over here. I should have left myself some room. Let's see if we can slide all that over here to give ourselves some room. So again, I'm going to multiply my top and bottom here by our missing factors. And remember, we have to multiply the bottom by the same thing. So now we have to simplify across the top. So on the bottom, we've got our common denominator. Now on the top, we've got to FOIL that. Now we had just factored that, so we know what we're going to get when we FOIL that. We're going to get 2b squared plus 9b plus 9. And then we've got to distribute that 3b into that. So we're going to get 6b cubed and 27b squared and 27b. And then we've got plus this 3. And we should theoretically try to factor this to see if anything would cancel out. I can see here all those are divisible by 3, so we could factor out a 3. I can see here that if I try factoring by grouping, I can look ahead and tell that this isn't going to factor. So this is as far as we can go. And I've got a 3 and a 2 here. Those can't be simplified, so this would be our final answer. So again, let's just recap what we did. Let's go back to kind of our easier problem. We are looking at our denominators and finding out what's missing. So when I'm looking at this fraction, what we started with, I'm looking to the other fraction to see what am I missing. I was missing 5n plus 3, so I had to multiply top and bottom. And now when I'm over here, before I added this stuff, we're missing the n minus 4, so I had to add that. So we're always trying to add what we're missing in the denominator, and we add it by multiplying top and bottom by the same. Once all the fractions have the same set of factors on the bottom, then we can add across. And then lastly, as the recap, if it was a subtraction problem, change this to addition and take the opposite of the top. So good luck on working on these problems on your own, and see you in class.
Are you ready? Are you ready? Oh,